Hello everyone, my name is Ove Pettersson and I'm the CEO of Plantagon, and I'm very grateful that we have been invited here to talk about our demonstration plant that we'll build in Linköping, 200 kilometers south of Stockholm. And what we will do there is actually to build a 60-meter high office building. And in the facade, how incredible it can sound, we will grow about 500 kilos of pak choi, which is a salad very common in Asia, because it's a demonstration plant mainly for the Asian market. Plantagon was founded 2008, but the main reason was actually a question asked 6 years before, and it was asked by a man called Oren Lyons, extremely famous man in UN and other likely organizations. He's a man from indigenous people called Onondaga Nation, and he asked a Swedish entrepreneur, Hans Hassle, if he knew anything else they could earn money on than selling tobacco. That was actually the start of why Plantagon exists today. They actually founded the company then 2008, and Onondaga Nation has then invested a lot of money in Plantagon to find solution for how to feed the future megacities in the world. The report you see to the left here is actually from Swedish government. We were appointed the most innovative country 2012, and they actually chose our project in Linköping as a symbol, you could say, for all Swedish innovation. So we are part here of other companies like Skype and Electrolux. To do this, it's extremely many counterparties and corporations that we have established. In Linköping, we have an energy company called Tekniska Verken with extremely good solutions and for biogas production, also waste management. Discussion with them was actually what led to this symbiotic system thinking, that putting a vertical greenhouse between their existing actually factories to make an extremely visible demonstration plan of a symbiotic system. You will see all this in the end of this presentation, because I will show a movie, an electronic, the electronic house, the so-called BIM model, so that you will see exactly how this looks like. The other important company has, of course, been Sweco. It's a stock market company with very sustainable, good engineers and architects, of course, and also horticulturists that know how plants grow. We have also worked with universities like Swedish Agriculture University, SLU. Also the local university in Linköping, which is very specialized on eco-industrial processes, has been involved. And of course, you need a city. You need the land in city. So then Linköping is actually the first city in the world that has said that it should be a vertical greenhouse project performed there. We have done almost the same thing in both Singapore and Shanghai. In Singapore, we have done the discussion with a country because it's the same as the city. This is a little bit what was talked about before, but we often get the question, why should you grow food in cities? Why this crazy idea to build a 60-meter high office building and grow 500 tons of food in the facade in a totally closed system? We all know that the climate change is here. It's actually affect a lot of production volumes today already. Storms, etc., flooding actually destroy food. That is one reason why it makes sense to grow food in cities in closed systems. Another thing is that there are not that much Arab land left actually in the world, and there are a lot of land destroyed every day. In Linköping, we don't use soil. We grow in something called pumice. It's a volcanic stone, which you can use in the same process up to 8 years. So it's much, much more sustainable than using soil. And if you use soil, you don't contribute with new Arab land, which we actually do now when we use this pumice. Another rather terrible thing in the world today is water scarcity. Bahrain, I visited last year, they don't have any own water. They desalt every water they have. Of course, they import as well. I think the most famous example now is in the US, California. But if you take the amount of water you need when you grow 1 kilo of salad on free land, it's actually 250 liters. Don't ask me how they calculated that, but it's an inefficient way of using water, of course. If you grow in a hydroponic system that is an open system, often used in many greenhouses today, you come down to 20 liters. If you grow in a closed hydroponic system that we have in Linköping, you come down to 1 liter. That is also a very good reason why you should grow food in closed system in cities. This is also a number of risks that also been mentioned before that actually the world now have to address and solve. It's rather horrible situations in many parts of the world. This is something I reflected when I started in Plantagon. I didn't know that we was only 2 billion in 1927. Today we are 7.3 billion and we are heading towards 9 billion. Do someone know how long time it takes to count to 1 billion if you count one number each second? 30 years. So puts things, I think, in a perspective. This is also showing that the urbanization is taking place all over the world. It's not a trend in Europe or so, it's all over the world. And then you also have the city in themselves. It's only 1.2 of the Earth's surface that they occupy. But if you see the energy used by cities and all other kinds of resources, you realize that it's good also if city planning now can benefit from actually putting food in center of sustainable city planning, because then you can transfer waste. You don't see that on this picture now, but it's a lot of waste, of course, flows in cities that isn't managed probably today. Our answer to how to do this, and this is not the only answer, of course, and this is for industrial production of food in totally closed system. But we launch now a term that we call agritecture. The reason for that is that our experience now is, at least, that you need to combine 3 competences when you develop industrial food production lines in cities. And that is, of course, you need to know how to grow. You also need to know what kind of technology you should use. You need to know how to combine different types of technologies to make efficient system working. But least but not last, you really need to have good knowledge about real estate and real estate development. We have example in Stockholm now when a architecture firm had an assignment to make a small place green and also should include the production of food. They had no clue of how to grow. They didn't know about the technology. So for that project, it actually became a bad thing. It got ugly, it didn't work, and people didn't want to go there. So we got an assignment and applied this agritecture principles on this. And now we actually see that we can grow food in this rather limited environment that was. This is a result also after a long discussion now what we actually do then. But if you should produce a lot of food in cities and build buildings or extend existing buildings or retrofitting projects, etc., you need actually to work very likely like a architecture firm do today. You, in the beginning, have some kind of phase where you conceptualize ideas. Those ideas need to be configured into real solutions. You have a number of technology companies today that can provide really, really good solutions. But you need to be able to implement them in a real estate, which not that many of them can actually. The last part that also is very, very important is, of course, to the operations of the urban agriculture farms. If you should make them economical viable, you need to run them every day, every second, year round, 24/7. If you should let people living in an area running these facilities, probably they fail because people go on vacation, they get sick, maybe they don't want to deal with their plants as there are other things popping up. So for us, this is a business model we use for all projects when we get assignments to us. This is a very interesting example of a real case now, which we call the Hanging Gardens of Stockholm. Could of course be the Hanging Garden of Oslo or any other city in the world. But we got an assignment for doing an urban farmers lounge on one floor. But when we got the drawings, we realized that we could actually expand this concept to also include a plant factory and a technology room underground. And then also implement a plant store and showroom on another level. And then you have this rather nice urban farmers lounge where people actually can be, interact with real food production, and so forth. This is something now that should be decided, we hope, before the summer to actually be realized. Another example also from Stockholm is that it was a space between two existing buildings. And then they asked us if we could do something for this space as well. And then we actually use the knowledge we have for our own vertical farm, and that is a double shell facade. In this case, we only have the double shell facade 40 meters high, creating a totally controlled environment to grow food in. In this case, we don't use our own technology, and we use other companies' technology. In this case, it's a so-called paternoster system, which go up and down all the time. And this rather small unit, you can actually grow up to 25 tons of pak choi or other vegetables. This is what you will see in the movie then. When we do new buildings, you need to integrate them with existing, if there are existing symbiotic system that you can use spill heat, for instance, or CO2 emissions that you actually can lead into the production of food. This is also something that probably is most economical viable when you're talking about industrial production of food, that you will increase the city's resilience towards food production not being able to be performed outside the city, because this will be a factory that produces enormous amount of food that actually can provide, in this case, in Linköping, it's 5,000 to 6,000 portions per day, 1.3 tons per day, and 500 tons per year. Something you realize when you talk about this industrial production of food is that food production in cities is very related to advanced city planning. All the disciplines involved in city planning, like water, transportation, waste management, architecture, etc., you need to include in these discussions. What we realized was that there are no standard for food production in cities. So we took the initiative to the world's first standard that actually been launched last month, and what is really interesting now is that standard has made rather big impact now, both at UN and ISO Global. So what ISO Global now is doing is actually to launch a new standard. It's called ISO 371.0. And for the first time ever, actually including indicators of urban agriculture for cities now to really think through how they should manage. And of course, with the standard for this industry that is global, that is also something that makes it much more easy, of course, to expand internationally, start cooperations all over the world regarding this. And when both UN and ISO Global do this, it will have an impact on how future cities will be planned for. Of course, if they start with 45 cities, there will be more and more cities then. This was a question I got before this presentation. Is it economically viable to do this? This is the business case for Linköping. And then you have, on the left side, you have the investment. It's a total investment of 300 million. If you have a factor of 1.15 of this, you have 345 million, and then you put a yield on that is 5%. You then get the figure you need to meet if you should have an investor for this project. And that figure is the operating net. And then you have two revenue lines from a vertical farm project like we do in Linköping. And then one is for offices, of course, where you rent out the office spaces. And then you also sell the food. Then you, of course, have costs to run the food and operate the food. But the interesting thing now is that with a rather modest rent and a rather modest price on the salad that we grow, the pak choi we grow in Linköping, even on that market, you see the first version there, we actually meet the requirement for yield. If you take the next example, if you just increase the rent also rather modestly to 2,000 per square meters and increase the price per kilo to 50, you see that is a rather big impact. And if you can increase it to 2,600, which is a rather low rent if you are in Stockholm, Gothenburg and Malmö, it almost meets the total requirement for yield from the investor. If you sell food today to private persons in the retail market, then the price in stores, I think you also noticed, when you have this rather small package of food, becomes 200, 300, maybe 400 kronor per kilo. So to put 100 kronor per kilo in Linköping is not irrelevant. It's quite possible. And then if you manage to do that model, then we will actually have a very, very profitable case in Linköping. That would be even more profitable if you did it in Stockholm, Gothenburg and Malmö. Now I will take a very short history lesson here. This is an existing industrial production of food line in Iceland, actually, where you saw a seed in the beginning of the track, and then you set the pace of the track until it matures, and then you harvest it like the man do there on the picture. And what the innovator did, the Swedish innovator here did, was actually to take this, you could say, conveyor belt and draw it around the stick. And by that, stack the growable area vertical instead of horizontal. And that is actually the prerequisites, the first prerequisite to take such a process into a city, because you don't have the space to put a greenhouse with several thousand of square meters in a city. Then he developed a very smart robot to move growing boxes, which then had led to a design of this. This design is the most famous design we have today, and it has been spread all over the world. Do you want to ask questions now, or should I put the movie on?
Yes, you have to put the movie.
Do you take the movie first? Yeah.
Real estate companies invest heavily in cities, yet we have used technology to add even more value to their development projects. This is our demonstration plant for a temperate zone, being built in Linköping, 2 hours south of Stockholm. It's a 60-meter or 65-yard tall office building, producing 500 tons or 1.1 million pounds of vegetables per year on its south facade. To illustrate how energy use and CO2 emissions could be lowered, we initiated this project as an industrial symbiotic system, a partnership between Plantagen, the local energy company, and the local biogas plant. The greenhouse uses district heating supplied by waste burnt at the power plant, and we also receive excess heat and carbon dioxide from a nearby biogas plant. What's left over from the greenhouse goes into the biogas digester. This way, we turn 3 different waste products into tradable goods and make environmental work profitable. Now, since we've started the project, we've developed even smarter solutions. In this pioneering project, all disciplines have to work together: architecture, construction, electrical, waste, water, industry, and others, all in one place. The greenhouse is designed to let as much sunlight in as possible. Yet, due to the multiple-story design, LED lights are used to provide additional lighting, without creating as much heat as traditional lighting. However, from time to time, we have more heat than we can use, and this is stored in boreholes beneath the building to warm the office side of the building during winter. Vertical farming in a closed environment free of pesticides and other pollutants requires a double-skin facade. Otherwise, it will not work. This technology allows the control of airflow and heat in an economically and environmentally viable way. Plants consume CO2, and so we need to boost the levels of CO2 in the greenhouse. And since the cleanest CO2 there is comes from our own breath, we push the CO2 emitted from the hundreds of people working in the building to the plants. And we take the oxygen given off by the plants and push it into the office building. This sets a new standard in indoor environments. It's almost like creating a lung for the city. We irrigate by filling the cultivating tract with about 2 centimeters or 1 inch of water. The excess water is drained away. Water, not absorbed by the plants, is then filtered and reused on the first floor. As the plants grow, they need more space. By optimizing spacing in 2 directions during plant growth, Plantagen significantly increases production. The individual plants are removed from their growing pots, and the pumice is sterilized and recycled. We'll invite local organic growers to sell their produce at our Planta store. In short, what we have shown here is a profitable, super green real estate and urban farming solution. One that produces the best indoor climate for both people and plants, and makes extremely efficient, local, safe food production possible. A solution that will put food on our plates for decades to come. We save 3.6 million kilometers or 2 million miles of transportation, 1,000 tons of CO2 emissions, 50 million liters or 13 million gallons of water, and 60,000 square meters or 15 acres of land. With this transformative solution, we produce 100% clean food, free of pesticides and other pollutants, for thousands of people, using fewer resources than any other solution on the planet. It's scalable, efficient, and it's fresh. During the next 15 years, the city will undergo major development. Then, we'll not only store our excess energy, but sell it to our neighbors. Perhaps this will be the first truly symbiotic city in the world. It's something we not only dream about, but something we're working hard to realize every day, in everything we do.
Ja. Takk, spennende. Dette jo da ikke science fiction, men snart realisert I Linköping.
Yes, it is. Hopefully start to build actually the beginning of next year.
Yes, so I guess you get groups of visitors from not only from Norway, but from other places too. I have a question for you. I think the movie got an answer, but what about pesticides and kunstgjødsel?
No, it's free of that because it's a totally closed system, and also the fact that we use pumice, the volcanic stone, which also will be clean after each cycle in a microwave actually. You will reduce the risk for diseases and stuff like that enormously. So no, we shouldn't use that.
Okay. And what is the cost of operations for the vertical garden per year and per kilo greens?
The cost, as we showed in the business case, is around 10 million Swedish kronor. Then it's 3 tops 5 people working in this greenhouse facility. I don't have the figure actually per kilo, but 10 million divided in 500,000 kilos. I can't calculate that right now, but that's the cost. Yeah.
So how many, if you should provide Oslo with the pak choi, how many such buildings would you need?
How many live in Oslo?
About 600,000. Well, it's fast growing, but...
But as in Linköping we grow 500,000 kilos. It's not an optimized building. It's actually so that we can reduce it by half because the distance between the growing tracks are 270, and you don't need that. It could be half. But if you had 10 projects like Linköping, you would provide 50,000-60,000 people with food in every day then in Oslo.
Okay.
Yeah.
Okay. Thank you very much.
Thank you.